Welcome to CSSE 7023, Advanced Software Engineering at UQ. I'm Richard Thomas, and I'm stepping in to give you a bit of the content from week one while Thomas Christie is ill. So this week, we're introducing the whole idea of this course, and part of that is learning how to program in Java. So let's take a look at how to program in Java. What we'll be looking at is a quick overview of the idea behind Java. We'll compare Java and Python, assuming that a number of you are familiar with Python already, and we will look at some of the basic programming features of Java. So Java itself is what we call a general programming language, or general purpose programming language. So the intent is that it's designed to be used in many different problem contexts. It allows you to solve many different types of problems. So it's a very flexible, very powerful language. It has many features. Makes it a little more challenging to learn than some other languages, but it also means that it allows you to tackle very complex problems, and it has a lot of features to save you time in solving other types of problems. And Duke over there is our Java mascot. So Java is what we call a compiled language. And what this means is that we write our code in Java, and then it's translated into another format, which is then executed. And so that translation process is what we call compilation in computer science. And there's a few purposes for that. One is by compiling the code, we can do some checks to ensure some basic safety features of the code before we actually execute it. There's many optimizations we can do to the code because we actually process it before we execute it. And it also means that we can actually have a more compressed version of the code that we can then distribute. So it's a compiled language, and we will explore that in a little more detail a bit later on. Java is also what we call a statically typed language. So when we say statically typed, it means that we declare a type for something like a variable, and it is given that type when it's declared, and it maintains that type throughout its lifespan in our program. But that means in the compilation process, we can actually do some safety checks on values that are placed into variables because we know what's supposed to be there. Java is an object-oriented language. It's actually at its heart focused on being object-oriented. You may have used object-oriented features of Python, but Python is sort of a multi-disciplinary language. It's something that can cater for programming in many different programming styles. Java forces you to use an object-oriented approach that's intentional to narrow choices to actually try to encourage people to write well-structured modular code that's likely to follow better programming practices and lead to code that's easier to maintain in the long term. Java is what we call a memory-safe language. Python is also a memory-safe language. So are many other languages, but this is that we don't manage the computer memory ourselves. Some other older languages or lower level languages like C require you to manage the memory that your variables are using, which has its purposes and flexibility, but is also very risky and very difficult to do correctly. So Java and many other languages manage memory allocation for you. Java is also what we call a concurrent language. So it's built into the language that it supports executing different parts of the program at the same time. It does so in what we call a threaded manner. That's something we might get a chance to look at towards the end of the semester, but it's definitely not something we want to think about and worry about to any great extent, and definitely not at the start of learning how to use Java. Concurrency is quite a complex process to get correct. But Java has built-in support to write concurrent code using what is called a threaded concurrency model. Again, that's something we will think about much later on in the semester if we get there. Java also is designed around the idea that it will easily support having code executing on multiple computers and then synchronizing with each other and using a distributed computing model. But that's something for a much later course. And if it's something you're interested in, it's something you can aim to get to possibly towards the end of your program in CSSE 6400 software architecture. So Java, it's been around for quite a while now, but obviously there were predecessor languages to Java. So in a sense, we consider it a successor to languages like Common Lisp and Simula and Clue and Smalltalk, which were some of our core or original object-oriented languages. So particularly Simula and Smalltalk basically provided the core ideas of what is now object-oriented programming. And Java builds on that lineage. Interestingly, though, it decided to follow a different approach in its syntax. So the syntax of Java is similar to C and C++ and C#, basically because that was a nice marketing move and it attracted people who are familiar with C or C++ versus other languages like Smalltalk, which seem to scare some people. So Java is one of our more popular languages around. So we've got this graph from Stack Overflow, which tracks trends by questions per month of what people are asking about. Python hit a really high popularity in 2020, 2022. It's dropping, but obviously it's still quite popular. And then we've got, where are we? Python, red. Oh, sorry, Python, yes. Java, brown, is, popularity has declined, but it's still our third most commonly accessed language or questioned about language on Stack Overflow. So it's still very heavily used. So what does a Java program look like? So we've got to do our classic hello world. So first program we write in almost any language we start to learn is hello world. So this is hello world. Oh, there's a lot of stuff there. So way down here, the kind of obvious thing is, oh, it says hello world. So yes, that's where we print it out. And it even says print ln or print line. So it's print and it finishes the line. So that's why it's called print line. So we can't add anything after that line on the display. And then we do another print line. And obviously we just give it the text another line. System.out.println seems kind of cumbersome. There is a purpose to that, but yeah, it is a little cumbersome. So what it is basically some prefixes here. We're saying print line. Key thing to remember is Java is an object-oriented language. So you can't have a function. You have to send a message to an object, and that's out. So I'm sending the print line message to the out object, passing it the parameter hello world. And so in this case, we're doing this is the object that receives it, and out stands for standard out. So it's the console to which this print line will send its actual data. And so system is just, that's the actual encapsulator that knows about standard output and standard input and standard error and all those other things. So it's saying from the system, we want to send something to standard out, and we're going to send it the message print line, which is going to be the hello world. Okay, back up to the top. We said everything in Java's got to be an object. So we have a class structure that describes our objects. So class hello world is the class that describes the object containing our functionality. And that's also the name of the file, hello world.java, that's going to contain the code. And then I've got this public static void main string brackets args, which is horribly ugly. We won't worry too much about it. We will come back and talk about those aspects of it in detail, but we're saying this is the main method, which is the starting point for my program in the hello world class. The args is literally I can pass parameters to my program, so there'll be an array of strings passed in, but we will come back and talk all about that later in the semester. There's two styles, well actually there's three styles, but we're only going to worry about two of the styles of comments in Java at the moment. There's double slash, which is a comment from this double slash to the end of line. And then there's a multi-line comment, which is slash star, and as many lines as you want, star slash. So we've got our file, hello world.java. And so we said we have to compile this. Well, what does that mean? Well, there is a actual program called javac, which we execute, and we would literally type in the command line javac space hello world.java, and it would find the hello world.java file, and it's going to compile it. And the end result is we're expecting a hello world.class file. So that class file contains what we call bytecode. And so that's the code that the Java environment executes. It's not machine code. That's why we call it bytecode. It's not machine code, so it's not directly executable on the computer. It's actually intentionally a transportable executable body. And so I can take that hello world.class file and run it on a Mac or a Windows machine or a Linux machine or an IBM mainframe or a web server, and it will happily do that because bytecode is portable. It's not meant to be readable. You can actually open the hello world.class file and read it, and there is a syntax to it, so you can actually understand what it looks like and that, but we're not going to touch it at all in this course. So javac command compiles the hello world.java file or any Java file into a class file, which is the executable bytecode, and then we've got to run that. And so we've got the Java command, which runs the application. So it takes the class file and interprets the bytecode and executes it to give me the actual running application. Conversely, Python is what we call an interpreted language. So it doesn't compile the code. It executes the code basically line by line. That there is the Python engine, which reads your file, and it reads a line and it does what it says it's supposed to do, and it reads the next line and then does that as well. So there's benefits of both compilation and interpretation. So we've mentioned things like with compilation, you can do safety checks before you actually generate code. You can do many more optimizations. And in the case of Java, you can then generate this transportable code body. But interpretation is it's easy to actually just experiment and write some code and try it out and see how it goes. And it's a key characteristic of why Python is currently popular. So we've talked about how we compile code in Java. So that's the process. In general, you're probably not going to actually do it manually by saying, here's my Java file, please compile it javac. Now, Java, take the class file and please run it. In most cases, you're just going to use an IDE to do that. We're recommending that you use IntelliJ. And so you can download IntelliJ if you do a search for that. As a UQ student, you can actually register to get access to the professional version of IntelliJ. which has a few features that you might want to use, so it's worth doing that. And so you can download it and then use it for free. And in IntelliJ, it provides you a nice environment for editing code and debugging code, but also running it. So you can just say run, and it will compile the code and run it for you. And it'll do some syntax checking and code highlighting and code recommendations as you're typing. So it's got a number of benefits and is fairly user-friendly. We don't require you to use IntelliJ. There are many other IDEs out there like Eclipse and VS Code and NetBeans, but IntelliJ is popular and it's pretty user-friendly. All right, so this is Java. So now let's look at the parts of a program. So variables. So first off, this is Python, not Java. But if you're familiar with Python, there's a couple of things to be aware of as similarities and differences. So Python, variable holds stuff. So you can think of it as a box in memory that's got a name, and you can stuff things into it. And then Python, being what we call dynamically typed language, doesn't require us to declare a variable before we use it. So I can just say x equals 1, and we've now got a variable x that contains the value 1. And I can print it out and do something with it. And then it'll happily let me say x equals 1.7, and it's just a different value being put into the box. Or x equals the string hello, and again, it's a different value being put into the box. So it's just something that stores something. And then I can refer to that variable name somewhere in my program to retrieve the element that's stored in the variable. So when I say print x, I get whatever is the current value of x. Now there is a drawback of working this way, because it's actually got to dynamically allocate memory every time you put a different type of value into a variable in Python, which is actually a fairly inefficient process. But it makes life easy in that we don't have to worry about types so much in Python. So Python, you allocate variables by just using them. You don't have to pre-declare them. You don't have to tell it what are the types of things that go into a variable. There are type hints in Python, but you don't have to specify the type of things. And you can put different types of things in the one variable. It just changes what its value is as you put different things into it. So in Python, you've got the type command, which will actually tell you the type of variable, which is actually necessary because you can't figure it out any other way in the program. So when I say x equals 1, the current type of it is it's an integer. And you should note it says class int. It's actually really a reference to an integer object. And then when I say x equals 1.7, the type is now a float. And when I say x equals the string hello, then the type is a string. So Python is happy to let you put different values of different types into a variable. It doesn't restrict it to a specific type. And that's one of the reasons why we call it a dynamically typed language. Java can do this in a limited way, but being a statically typed language trying to enforce safety, it's going to say some of these things are bad ideas. No, you can't do it. So in Java, variables have a type, like in Python, but we have to tell the compiler which type we want it to be. And so when we declare a variable, we specify its type. And so we have to declare the variable before we can use it. So if I want to use x, I have to say, here's x, and I'm going to make it store integers. And I can say things like x equals 1, x equals negative 5,000. They're both integers. But if I say x equals 1.0, the compiler is going to tell me, no, you can't. 1.0 is a double. It is not an integer. No, you can't store it in x. Similar, x equals the string 15. It will say, no, that's a string. It's not going to try to convert it from a string to a number like JavaScript will do. It's just going to say it is not allowed. So what are the types? So it's possibly, initially a little bit confusing, is there are two types of types, just to confuse people. So there are primitive types and reference types in Java. So primitive types are simple values. And the primitive types are then Boolean, which is a single bit, so it's true or false. There is a type called byte, which is 8 bits, which is some integer value in the range from a negative 128 to positive 127. There's char, which is a 16-bit character in the range from 0 to 65,535. There's short, is a 16-bit integer, which is negative 32,768 to positive 32,767. And so these are potential values of those types. So Boolean, true, false, byte, negative 100, positive 120. The character is a single character. A or 6 or Z or ampersand would all be single characters. Short is just, again, an integer, so something within that specified range. Int is 32 bits in size, so it's negative 2 billion and something to 2 billion and something. And it's just another integer. It's just got a broader range. Long is also an integer value, but it's 64 bits. So it's some ridiculously low number to some ridiculously high number is your possible range of values. We have floating point values. So there's float and double to represent them. So float is a 32-bit floating point value. So it has 32 bits of precision in the floating point, and then a double is double that, so 64 bits of precision, so just basically double the precision in the floating point component of the value. And then also a broader range of values that there can be. You can represent doubles just as a normal floating point value like 27.8. Or using exponentiation notation, negative 1.9 to the exponent of 10 to the 200. Note, if you just enter floating point values as literals in your code, they're doubles. If you want them to be float, they have to be, the last character has to be an F to indicate it's a float. And in many cases, we just leave them as doubles. So those are all the primitive types. And one of the characteristics of a primitive type in Java is that it is the value held in the variable itself. The other type of type is a reference type. So this is the variable refers to something else. So it's an object. So it refers to an object of some class. And so that object is sitting somewhere in memory. Java manages the memory allocation and management and movement of that object. And then the variable itself just is a reference to it. So it keeps it easy for the compiler to work with. We'll, again, come back and explore that idea of references more as we explore using objects later. Now, scope of variables. This is something you need to be aware of, that a variable doesn't exist until you declare it. And then Java has what we call a scope, which is a block of code. And if I declare a variable in a scope, it's not visible outside of that scope. And Python does not worry about that. It doesn't think about scope to a significant extent. So in Python, if I had some structure like this. If 5 greater than 4, z equals 2, else z equals 3. It's quite happy to say, yep, you've got a single z, which can be either 2 or 3. Here, Java will say, well, if I do if 5 greater than 4, int z equals 2, int z equals 3, and then I say, let's print line z, the compiler is going to complain and say, I don't know anything about a z, because there are two different, come back here. There are two different z variables that are inside of these blocks of code. So blocks of code are opened and closed by these braces. And so inside the first branch of the if, I've declared a z variable. And inside the else branch of the if, I've declared a different z variable. So these are two different variables with the same name, which is terrible practice, but it's for the purpose of an example. And they're declared only and visible only in that block. So I can't use them outside of the block because they don't exist. So if I did want to use them, and obviously have some condition which actually could alternate, I would just have int z before the if statement somewhere, and then inside of the if statement it could happily use z because it says, oh, z already exists, so I can use it inside these blocks. And then after that if statement and its two blocks of code, I can print z because it was declared before the if statement, so it's still known after the if statement. Now, this is something that's not unique to Java. Can still lead to interesting problems in other languages like Python. So we say, here are two int variables, x and y. And then I've got some code, and then suddenly I do something like y equals x plus 1. But I've never actually assigned any values to y or x. So what's happening here? Is that legal? Is that, what's value could it possibly be? Is it just going to be random numbers in y and x? It actually depends. So, depending on circumstances, particularly where these things are declared, it could be that x and y had their memories zeroed, and so they're going to contain values that look like 0. So y equals x plus 1 will be probably 1. Or the compiler is going to say, no, those things weren't pre-initialized, so nope, you cannot use them, and it will then complain about it. So this is something about where the variables are declared. We will consider those different scenarios as we look at different parts of Java, not going to worry about where that happens. Just the key thing is always initialize your variables. Even if you know that it is meant to be pre-initialized to 0 by zeroing the memory, initialize them anyway so that someone reading your code knows what is supposed to be happening and knows you know what's supposed to be happening. Okay, so some characteristics. So basic arithmetic. You've got a plus operator, minus operator, and a multiply operator. They're basically the same between Python and Java, except for this note about overflow. Python, there is no maximum integer value or minimum integer value. So if you add two really big numbers together or multiply two really big numbers together, you just get a really big number that occupies a huge chunk of memory. In Java, these things have fixed size. We said that, they're going to be 8 or 16 or 32 or 64 bits in size. And so we then have the potential for overflow. So if x plus y, where they're both integers, is going to end up with a number that's bigger than the maximum value of 2 billion and something, we get an overflow. And it just overflows. What happens is it says x plus y, that's bigger than the maximum value of an integer, and it wraps around and becomes a negative number instead of being the bigger positive number. So it's something to be aware of, particularly with integer arithmetic. But if you've got a long, it's got to be a really big number before you need to worry too much about it. And Java has a library called Big Integer if you do need to worry about it. Plus, minus, multiply. What happened about division? It's slightly different. So 3 divided by 2 is 3 divided by 2. Oh, hang on. What's going on? We've got to remember the types here. 3 divided by 2, that's integers. 3 divided by 2, that's integers. Yep, it's going to be the same. I'm going to say 3 divided by 2, it's 1. And then 3 by 2 in Python is now 1.5, whereas we've got integer division, whereas there is only integer division with integers in Java. 3 divided by 2.0 is going to give me 1.5. Java. It will do some type conversions for me. So when I do something like this, 3 divided by 2.0 is going to say, oh, that's a double. So when I do the division, you're going to do double division, not integer division. Same 3.0 by 2, that's a double. So do double division. 3.0 by 2.0 is obviously going to be double division, so they're all going to be 1.5. Logic operators are basically identically the same, except double equals. Double equals is only the same for primitive types in Java. So it will compare the values and give me a comparison. Reference types, it compares the memory locations of the two variables, which occasionally I do want to do, but often is not what I want to do. There is no triple equals in Java, like in JavaScript, but there is an alternative way of doing that. And or not for logical expressions is the same basic logic. It's just the syntax is different. So double ampersand is and, double vertical bar is or, and exclamation mark before a variable is not. So sequence. So sequence is just executing statements in sequential order. And so we talk about sequential logic or sequential code, and it's just we have a set of statements that are executed one at a time. So I say here int x equals 1, int x equals 1, int y equals 2, int z equals x plus y is going to say x has the value 1, y has the value 2, add them together, store the result in z, which is 3. So I can say print line z, it gives me a 3, and then I can still keep using those variables, so I can assign a new value to x, which is 10, and just in ordered step. And then we use semicolons to indicate the end of a statement in Java. So unlike Python, where you just end a statement, move on to the next one, you have to explicitly indicate it with a semicolon. In Java, but stylistically, you should still have only one statement per line. And as we've said previously, if I'm going to have variables, I have to declare them and declare what type they are and initialize them before I use them. And then calling a function. So Python, you can have standalone functions. So I can do print hello world. It just calls the function. In Java, there is actually no standalone functions. They're always methods of some class. So we've got to send a message to an object. So that was our system.out.println saying from system, grab the object called out, send the println message to it with the parameter hello world. But in the end result is we're executing the println logic. just happens to be we're executing it on output object. So the string hello world is displayed to standard out. Defining functions, we've already seen the example for hello world, but as we said, there's a bit of cumbersome stuff around that. So in Python, it's just, I want a function. So def, function name, parameter list, body of function. Everything in Java belongs to an object, so I've got to have a class. I'm going to have an arithmetic class. I'm going to have an add method. It takes 2 parameters. We have to say what type the parameters will be, which is integers. And we do our logic, which is return x plus y. We're returning a value. So I have to tell Java what type the function returns. So add returns an integer. It takes 2 integer parameters, which are called x and y, internally to add. And then static is saying that I want this add method to be available even if I haven't created an arithmetic object. And so it means I can just say, import the class arithmetic, and then do arithmetic.add to execute the add function without creating an arithmetic object to do so. So we'll revisit static again in a couple of weeks. We also have conditional logic. So sequential logic is fine, but at some stage I need to do something interesting, so I need to make a choice. So selection is the idea of conditional logic. Do something in some circumstance. And so syntax, we have an if statement in Java, which is if condition, which must be in parentheses, and then the code to execute is the body of the if statement. And we should always include it in a block. And the thing is, if there's more than one statement in my condition, it must be in a block. So by style, always put your body of your if condition in a block. Then we have else. So unlike Python where you have an elif, you have just else. And if I want to have if, else type logic, it is if else, then if the next condition. And so its body, and then else and its body. So I've got if this condition 1 is true, execute body 1, else if condition 2 is true, execute body 2, else if neither of the others were true, then execute body 3. The other statement is the switch statement. So there's actually 2 styles of switch. This is the old style, just because we're looking at it, because most examples you'll find online probably use the old style. This new style is new for a reason. There are benefits to it, but we'll think about them later. So switch statement says, give me some variable. And based on the value of that variable, we can do something. And so the cases are what to match the value of the variable against. So we say, okay, I've got a variable. Based on its value, if it corresponds to literal 1, then execute body 1. If it corresponds to literal 2, execute body 2. And you can have as many cases as you want, like you can have as many else if as you want. And lastly, if its value doesn't match any of these literals, then by default, do body 3. Now, these breaks are important. So it says, if it matches literal 1, execute body 1. If there's no break, it will then execute the code in body 2, which probably you don't want to do. So 99.9% of the time, you want to put a break at the end of every case body to say, when I'm finished, exit the switch statement. So you can look at the switch.java on Blackboard as an example of some of these structures. And then we've got iteration as another type of logical structure, in that I want to do something more than once, which is really quite common. So there's three types of iterative structures or loops in Java. So two of them are the while loop and the do while. So it says, while this condition is true, execute the body. Again, syntax, must have the parentheses around the condition, and then you should always have the braces around the code block, which is the body to execute. And so we call the while statement a pre-tested loop, because it's going to say, if the condition is true, execute the body. So it's going to check, and if the condition is false, it will actually never execute the body. So that's why we call it a pre-tested loop. Do while is just a post-tested loop. It says do the body while the condition is true. So it's quite similar. The only real difference here is it guarantees that the code in body is executed at least once. And then if the condition is false, we then stop. If it's true, we just do it again. So a very simplistic example could be, I've got I is an integer initialized to 0. Then while I is less than 10, I've got my block of code. I'm just going to say print I. Oh, and then I'm testing I to see if I should exit the loop. So we need a way of changing I. So I'm going to increment it. And this double plus operator is the increment operator. So I'll just add 1 to the value, which is convenient, but it's the same as saying I equals I plus 1 or I plus equals 1. So those are our while and do while loops. And then we've got a for loop. There's actually two types of for loops. We're just going to look at one now. So there's the for loop, and then there's a for each loop. Revisit the for each later. So for has three parts to its basic condition. It's got an initialization component, a test component, and an update component, and then there's the body inside the code block, which is what gets executed if the test allows me to. So what happens here is the init is initialization. So initialize something that's going to be used to test whether we exit the loop or not. And then we do the test. So this is also a pre-test loop. So possibly it's going to run init, and then it's going to execute the test, and it's going to say, test is false, we're finished. Or we're going to initialize something, we're going to test it, and if it's true, we're then going to execute the body. Then we're going to execute the update, which should change the value. And we're going to test it again, and if it's now false, we're out of the loop. And this can go on and on and on, so we only ever do the init once, but we then do the test and the body and the update repeatedly until the test is false. And so an example is, again, quite trivially, for int I is 0, while I is less than 10, I plus plus. So initialization is declare a variable I of type integer and initialize it to 0. My test is while I is less than 10, and my update is add 1 to I. And then my body is print I, so it's just going to print out the values from 0 to 9. So when I is 9 and we increment it, we then fail the test because I is 10, so it's no longer less than 10, and we exit the for loop. So we've already mentioned a bit about this syntax. There's all a purpose for it, but it's some basic structure which you'll just make use of at the moment. And so we said everything's got to be inside of a class because we're dealing with creating objects. So you've got a class which has some name, let's say XYZ. We have the visibility. So for the moment, we're going to say every class will be public. We'll talk about what that visibility means and when we should change it later in the semester. But a key thing to note is whatever the name of my class is, my Java file must be the same name. So XYZ class must be in the xyz.java file. And then you've got the main method, which is the code that is executed when the program starts. So public static void. So public is visibility. Again, we're going to come back and talk about what that really means. It's just meaning I can access it at the moment. Static, we said, is so we can execute it without creating an object of type XYZ. We just need to know about the class. Void is saying I've got a main method. It doesn't return anything. So void is a special type in Java to say nothing is returned here. And then it's got a single parameter, which is an array of strings, which is what the empty square brackets means. So args is my parameter, and so the type is string array. And so that's any parameters that are going to be passed into the program, and we'll look at how we do that and access them again later in the semester. And then you've got the scope for main, which is the method. And so the code you want to execute inside of main goes here. You could declare other methods outside of main. I could have my public static int add, which takes x and y as two integer parameters and adds them together and returns them. And so I would have my own next method. And then I've got a close of block, which is the end of the class. So I can say, here are all the things that belong to or are inside of the XYZ class. So I mentioned there's some example code on Blackboard. So just look in the week 1 folder to find that. So a couple of them have been referenced already, like Hello World and Switch.java. But there's a loops.java, which gives you some examples of playing with loops, and also how we can use our increment operator. There's a for each Java, which is an example of the for each loop rather than the simple for loop. And there's a recursion.java, which is an example of writing recursive code, which you probably should take a look at and should become familiar with. So that's our quick flying introduction to Java. But it's a basic coverage to give you enough to get started. You can actually start writing little simple programs, which leads us to, you really actually do need to start writing some simple programs or you're not going to learn Java. And you've got a problem set due at the end of week 2, so you really do want to start writing them. So on Blackboard, you should see a menu item for Shifu. There's also a link to it from the week 1 folder. And it has a set of exercises for most weeks in the semester. And so there are a set of exercises for week 2. So Shifu is an environment we've created here at UQ. It's a simple programming environment and a simple programming tutorial tool. And what it does is it gives you an exercise. It describes what you need to do. And then it gives you a window where you can type in your code and you can run it. And then it'll show you the results, including errors. And so those results then can help you fix any possible errors you identify. And you can keep doing that until the code works. And these exercises are actually worth marks. So you need to do them. And overall, they make up 10% of your final grade. So they're easy marks, but they're intended to be practice and getting an opportunity to write some Java code to cover each of the key topics we're going over throughout the semester. So I strongly encourage you to look at these examples and to then start working on the Shifu exercises to get some Java programming practice before we release the first assignment, and you need to actually do something more significant in Java rather than just some simple exercises. So go tackle Shifu. He may be a little frustrating initially getting familiar with Java, but the intent is it automatically tests your code and gives you some feedback so that you can hopefully fix errors and actually learn from your errors and learn a bit of Java along the way. So that's it for this week. That's our quick introduction to Java. We'll talk a bit more about the actual course structure next week, and we will give you some more examples to work with before moving on to the next topic. If you've got any questions, please raise them in the Ed discussion forum.